Hello guys, welcome to my YouTube channel. Myself Chandan, studying at Sri Venkateswara College of Engineering for SEM Audi section. My topic is RSA application in public key encryption. Introduction to RSA. RSA stands for Reverse Schema Administration, named after the inventors. It is one of the first public key crypto system widely used for secure data transmission. The security of RSA relies on the difficulty of factoring large prime numbers. Importance of public key encryption. Public key encryption allows secure communication over an insecure channel. It uses two keys, and public key for encryption and private key for decryption. This system eliminates the need for sharing a secret key beforehand. Key concepts of RSA. RSA involves three main concepts: key generation, encryption, and decryption. Each user generates a pair of keys consisting of a public and private key. The keys are derived from large prime numbers, ensuring their uniqueness and security. Key generation. Key generation starts with selecting two large prime numbers P and Q. These prime numbers are multiplied to compare n, which is used a part of the key. The tolerant in calculation as for later use in encryption and decryption. Calculating the public key. The public key consists of modulus n and the public component e. The value of e is chosen to be relatively prime to xi. Common choices for are 317 or 65537 due to their properties. Calculating the private key. The private key is derived using the modular multiplicative inverse of modulo. They ensure that the product of E and D private component is congruent to 1 modulus. The private key allows the decryption of messages that were encrypted with public key. Encryption process. The encryption and a message must first be converted into an integer m. The encryption message C is calculated using the formula C is equal to m power e. This transmission ensures that only some with the private key can decrypt C. Description process. The description of the message involves using private key D. The original message m is recovered using the formula m congruent to C power D. This process demonstrates the mathematical symmetry of RSA applications, encryption and decryption. Modular arithmetic expand. Modular arithmetic involves calculation with reminders after division by a modulus. In RSA, it ensures that the number remain meaningable even when dealing the large integers. This property is crucial for both encryption and decryption process. The role of prime numbers. The prime numbers are integral to secure of the RSA algorithm. The difficulty of factoring the product of large two prime numbers RSA securities. Choosing sufficient large prime numbers is essential to prevent the brute force attacks. Security consideration. The security of RSA increases with the size of the key n. Common key size today are 2048 bits or larger. The security. As congruent power grows, longer keys are necessary to maintain security. Potential attacks on RSA. Common attacks include factorial attacks, timing attacks, and chosen attacks. The most prominent threat in the factorization of n into the prime concepts. Mitigation. These attacks requires ongoing advancements in key generation and encryption techniques. RSA in practice. RSA is widely used in various protocols, includes SSLs or TLS for secure web browsing. It is also employed in digital signature to verify the arithmetic of messages. The versatility of RSA makes it an cornerstone of modern cryptography. Digital signatures with RSA. Digital signatures provide a way to validate the automatica of message. The sender signs a message using the private key, allowing recipients to verify it with the public key. The process ensuring both integrating and non-replication in communications. RSA and certificate authorities. Authorities CAS and RSA to issues digital certificates. These certificates automatic that identify of enter in the network. The use of RSA ensures trust in online translating and communications. Limitations of RSA. RSA encryption is relatively slower compared to systematic encryption method. These limitations makes it less practical for encrypting large amount of data directly. Often RSA is used for encrypt symmetric key instead of actual message. Hybrid encryption system. Hybrid encryption combines the strength of RSA and symmetric encryption. RSA is used to exchange symmetric keys securely, while symmetric encryption handles the bulk data. This approach balances security and efficient in data transmission. Hybrid encryption system. Hybrid encryption combines the strength of RSA and symmetric encryption. RSA is used to exchange symmetric keys securely, while symmetric encryption handles the bulk data. The approach balances security and efficiency in the data transmission. Features of RSA. While RSA remains widely used, achievements in quantum computing pose as threat. Quantum computers could potentially break RSA encryption through Shor algorithms. Search in quantum resistant algorithms is essential for future security. Summary of key points. RSA is a foundation public key encryption system that relies on modular arithmetic. It is based on the difficulty of prime factorization and the use of key pairs. Understanding RSA's mechanics is crucial for appreciating its role in secure communication. Conclusion. RSA continues to be a vital tool in cybersecurity despite evolving threats. Ongoing research and adaptation are necessary to ensure its effectiveness. As technology progresses, the principles behind RSA may evolve, but it remains significant. Thank you.